Okay, so today we are going to learn how to graph radical function. Radical function all the time is under the square or cube root. There's variable. We call it radical function. In order to draw the radical function's graph, first perfect square inside of the square root. Then you think of perfect square number, and cube roots and perfect cube number. Okay, and let's start it out with a table. And x and y here. Then, because square roots, think of perfect square number starting, because it cannot be negative, starting from 0. Where put the 0, square root of 0 is what? 0, right? Okay, and then what's the next perfect square number? 0, 0 square is 0. And the next one, 1 square, which is 1. And then what's the next one? 2 square, 4, right? And one more, what is the next one? 3 square?
9.
9. So those number you write here under the square. Okay, that one perfect square number. We make perfect square number. Then square root 1 is what? 1. Square root 4? 2. Square root 9?
3.
Good. So and we draw the graph. 0, 0 right here. 1, 1, 4, 2, and 9, 3. So if you draw a graph, it's like this. Everybody got it? So even roots function all the time, starting points there and then going that direction or other direction, but we call this one, you can call it vertex. So this is inside of square root making 0, that's vertex. Starting point 0, 0, and then graph is like this. Everybody got it? But cube root 1 is like the x, y, still same, cube root making 0, which is a 0 right there. And then cube root 0 is also 0, right? But now 0 cube is 0. 1 cube, 1. So that you can put it 1 there. What is next one? 2 cube, which is 2 cube is what? 2 cube is 8. 2 times 2 times 2, right? And cube root 1, that's 1. Cube root 8, that's a 2, right? But now, this odd number, odd root can be negative number. So negative 1, then cube root negative 1 is what? Just negative 1. Because negative 1 3 times still negative 1, right? So negative 8, cube root negative 8, negative 2 times negative 2 times negative 2. That becomes negative 2. Got it? So 0, 0 here, 1, 1 here, negative 1, negative 1 here, and 8, 2, and negative 8, negative 2. So draw graph is like this, right? So cube root all the time in the middle, we call it, you can call it vertex, and then that way and that way. Everybody got it? So with that, we can practice drawing a little bit. Okay, this is perfect square number, perfect square roots function, right? Then all the time table, x, y. But what you need to be careful, not just x, under the square, in this case x minus 2. X minus 2. Which one? That one making 0, you need to find x value. X minus 2 equals 0, what is x value, Cody?
2.
2, right there. And when x equals 2, so that means square root 2 minus 2, which is 0, right? This is we call it vertex. Everybody got it? And then you write x minus 2 one more time. Maybe 3 more times, and put it the perfect square number there. So perfect square number 1, next perfect square number 1, next perfect square number 2 square 4, 3 square 9, right? At the time x value here 3, x value here 6, x value here 11. Everybody got it? And those all the time function, you put this one there. You put 3 there, 3 minus 2, which is root 1, 1. You put 6 there, square root of 4, which is 2. 11, square root of 9, which is 3. This is x value, this is y value. X value, y value. X value, y value, right? X value, y value. So if we draw the graph, x, 1, 2, 2, 0 here, 3, 1, 6, 2, 11, 3. So graph something like that, right? This is 2. Everybody got it up here? Now, they're gonna ask domain and range. Domain is possible x value. So graph is from here starting and moving, keep on going that side. So x value cannot be smaller than 2, right? So x value is domain. So domain x bigger than or equal to 2. Bigger than or equal to 2. And range, possible y value. Possible y value is here above, right? You don't see any below, right? So bigger than or equal to 0. Does everybody make sense here? Yes. So we'll just one more. Now what here? So just under the square, that's we see only x. Then easy, because let's put 0 and then perfect square 4 and 9. You write it like that, right? So you put the 0 there. Then square root of 0 is 0. 0 times 2 is 0. Plus 1 is 1. Okay, let's do some mental calculation here. Square root 1 is 1. Times 2, 2. Plus 1, 3. You guys following? And let's put 4. Square root 4 is 2. Times 2, 4. Plus 1, 5. Are you guys following? So put 9. Square root 9 is 3. 3 times 2, 6. Plus 1 is 7. Everybody's got it up to here? Okay, so if we draw the graph, 0, 1 and 1, 3 and 4, 5 and then 9, 7. So graph something like that, and this is 1. So domain, x value right here, 0, bigger than or equal to 0. Range, y value bigger than or equal to 1, right? Y value bigger than or equal to 1. Everybody understand? Yeah, just one more, and we'll come back. Okay, so cube roots function. Then you think about what? Inside of this, under the cube roots, which make perfect cube number, you find it. Okay, so we started out x plus 2 equals 0 because we're starting out 0. Then x equals negative 2, right? You put negative 2, then cube root 0, which is 0. We're going to start it out right there. And then x plus 2 should be what? 1. 0 cube is 0. 1 cube is 1. X plus 2. 2 cube, which is 8, right? But cube roots, you do negative 2, right? Negative 1, negative 8. X plus 2, x plus 2. So now here move minus 1, minus 2 both sides, then x equals negative 1. You put negative 1, cube roots 1, which is 1. And you put x equals, solve it, then x equals 6. You put 6 there, cube root 8, which is 2. And then you put, actually negative 3 in this case, put negative 3, cube root negative 1, which is negative 1. And negative 10, right? You put negative 10 there, cube root negative 8, which is negative 2. Okay, if you plot the points all the time, this first, negative 2, 1, 2, right here, negative 2, comma 0, and negative 1, 1, negative 1, 1, and here, and then 6, 2, 6, 2, negative 10, negative 2, so graph is like that, right? And then that was negative 2. Negative 2, comma 0 right there, right? Domain range of the cube root function, all your number balls. Can be x value, can be anything, y value can be anything. Everybody got that?